I am Adam McMaster. I'm a research fellow at the University of Southampton in the UK, and I run the SuperWASP Variable Stars project. The project aims to find new variable stars and to take new measurements of known variable stars from the data produced by the SuperWASP exoplanet search. SuperWASP was a ground-based search for exoplanets using the transit method, so that's looking for the tiny little drop in brightness that a star has when a planet passes in front of it. The SuperWASP survey ran for about 10 years, and it took repeated measurements of 31 million stars continuously for those 10 years. So it has produced an archive of measurements of those stars covering that 10-year period, which is really useful if you're interested in studying the stars themselves. With this project, we are looking for stars that are either pulsating, physically expanding and contracting due to thermal instabilities inside them, or stars that are in binary systems where they happen to be lined up from our point of view, so one star passes in front of the other and you see a little drop in brightness every time that happens, or stars which are rotating with strong magnetic fields which cause variations in the brightness of the stars on their surface. So what we ask people to do is look at what are called light curves. That's basically a graph of the brightness of a star over time, and we're just looking for particular shapes in those curves. We show you some examples of what the typical shapes for these types of variable stars are, and then all you have to do is look at the graphs and tell us if the one you're looking at matches any of the examples. So the project has been running since 2017, and so far we have found several hundred new variable stars, and we've taken new measurements of countless numbers of existing variable stars in that time. So far we've published one paper in 2021, and we also are publishing an ongoing catalogue, an interactive catalogue on superwasp.org, which is updated regularly with the results of the project as it's running. Have a look at the results from all of the work that our volunteers have been doing, and this is a useful tool not only for you guys, for the public who have helped produce it, but also for astronomers. So the Zooniverse has helped immensely with this project. Without the Zooniverse, this project would not exist, because the data we're looking at is not the sort of data that we can search automatically with machine learning algorithms or AI. This is very noisy data. It's data that was not designed for what we're using it for. This data was designed to find the very clear transits, the drops in brightness of these stars when planets pass in front of them, and it was optimized for that purpose. We're repurposing it now for something new, and that presents all kinds of challenges. Those things can cause real problems for us. So without the Zooniverse, without this army of volunteers standing by to help us search through this data, we just wouldn't be able to do this.